Okay, we have gone through the first 3 rules of factoring. We've talked about GCF, we've talked about grouping, and we've talked about trinomials, both easy and difficult. In Module 8, we're going to meet our last 2 factoring rules. Now, the rule we're going to learn today is difference of perfect squares. The name of this rule is extremely important. It tells you what you need to have in your expression to even do this rule. So let's talk about vocabulary. What does the word difference mean? Well, from 1st and 2nd grade math, difference means subtraction. If I want to find the difference between 3 and 2, I'm subtracting them. So in order to do this rule, difference of perfect squares, we're going to have a subtraction symbol in it only. And that means there's going to be a term in front of the subtraction symbol and a term behind it. So to do this rule, difference of perfect squares, you need 2 terms, which is a binomial, connected by subtraction. Secondly, what does the word perfect square mean? Well, that word means a term times itself. You can have numbers that are perfect squares. You can have variables that are perfect squares. First, let's do the arithmetic and talk about the numbers. A perfect square number is a number times itself. So let's go through a couple. What's 1 times 1? Well, that's 1. So 1 is a perfect square. What is 2 times 2? Well, that's 4. 4 is a perfect square. What is 3 times 3? That is 9. 9 is a perfect square. What is 4 times 4? 16. 16 is a perfect square. And we can go on with this list forever and ever. When you multiply the same number twice, your answer, your product, is called a perfect square. So if you look, I have a list on your PowerPoint of the first 20 perfect square numbers. You need to commit that list to memory. You should not waver and know whether or not a number is a perfect square. If I ask you, is 169 a perfect square, you should all say yes, because you should know that is 13 times 13. If I ask you if 361 is a perfect square, you should all say yes, because that's 19 times 19. So it is very important in algebra that you know your arithmetic. You commit rules to memory. Now there's 3 dots behind that list because that list is never ending. I can go on after the first 20. I know 25 times 25 is 625. That's a perfect square also. But most of the times in an algebra class, we stick with the first 20. Okay, variables could be perfect squares. When you multiply a variable times itself, that expression you get, that product, is a perfect square. So let's go through a couple. What's x times x? X squared is a perfect square. Okay, what's x squared times x squared? That's x to the 4th. So that's a perfect square. What's x cubed times x cubed? Gotcha. That's x to the 6th, not x to the 9th. Remember what we learned: when we multiply letters, variables, we add the exponents. So x cubed times x cubed, the 3 and the 3 would add to 6. What's x to the 4th times x to the 4th? That's x to the 8th. That's also a perfect square. So if you look at my list, x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, etc., 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 are perfect square variables. Do you see a pattern? You should. If you look at all those exponents, 2, 4, 6, 8, those are all what kind of numbers? Those are even. So if a variable is a perfect square, it will have an even exponent. So to sum it up, to do today's new rule, difference of perfect squares, which is a way to factor, you have to have an expression that has all those key ingredients. It has to have a difference, a subtraction symbol. So it has to have 2 terms, binomial, connected by subtraction. It's got to have numbers that are perfect squares. So you have to have one of those numbers off that list. And your variable has to be a perfect square, which means it needs an even exponent. So if you look on your PowerPoint, I have a question. Which expression represents a difference of perfect squares? And there's 4 choices. Is A a perfect square, a difference of perfect squares? If I say x squared plus 4, is that a difference of perfect squares? No, it is not. And the reason why it's not is because it has a plus sign, and that's a sum. So that doesn't fit the rule. Cross it out. Is x squared minus 8 a difference of perfect squares? Well, it has the difference, the subtraction sign, but are both your terms perfect squares? Well, x squared is a perfect square. It has an even exponent, but 8 is not a perfect square. You cannot multiply the same number to make 8. So that doesn't fit today's rule. Cross that expression out. Is x minus 9 a difference of perfect squares? Well, it has the difference. It has the subtraction. 9 is a perfect square, but is the letter x a perfect square? No. X has an invisible exponent of 1. And to be a perfect square, your exponents have to be even. So cross that off the list. That's not a difference of perfect squares. So look at your last option. Is the expression x squared minus 25 a difference of perfect squares? Does it have a different sign? Yes, it has subtraction. Are your terms perfect squares? Is x squared a perfect square? Yes, it has an even exponent. Is 25 a perfect square? Yes, it's on the list. 25 is 5 times 5. So that expression, that last one, x squared minus 25, fits our vocabulary. So that's the expression I'm going to teach you how to factor. So it's very important that when we do the rule difference of perfect squares, we first make sure our expression has all those key ingredients. All right, see you in the next video when we actually factor.